Video, we're gonna build a CNN, a convolutional neural network with PyTorch. And let's start from import some modules in the PyTorch. And then from here, we're gonna start build our neural network. And to start with our neural network, we have to build a class first, and I will name it CNN. And firstly, it has to inherit from the module called n.module. And then our first function is definitely the init function. And here we need a super CNN, the class, and here we will put the self. You may feel not comfortable with the first three lines, but actually this is like a default operations. All CNN in PyTorch have to start with first three lines. And from here, we're really gonna start build our neural network. And usually the convolutional neural network follows some kind of patterns. You see here, usually it starts with the first convolutional layer, and then with the active function, and then with the pooling. This is like combo, and most of the convolutional neural network follow this pattern. And after this convolutional layers, we're gonna flatten our picture and put in a fully connected layer to do the classification. So here I'm gonna build the first layer. I call it comp1. And to put in our combo, we need the n.sequential to wrap it. So the first one is our convolutional layer. And there are several parameters I need to emphasize. The first one is input channels. Here is one, why? The one means actually our photos have thickness. The thickness for black and white picture is the thickness is 1. And for colorful pictures, the thickness is 3 because it has 3 colors, RGB. And output channels, I'm gonna set 16. And what does this mean? This is like the number of filters we have, and the more filters we have means the more neurons we have, which means it's more powerful because it can detect more features, more different kind of features, and summarize them. But too many filters, it's gonna make it overfit. Here I'm gonna set our kernel size. Kernel size I'm gonna set 3, and usually is 3 or 5. And here is the stride. Stride is the length of each step moved by the kernel. And our final one is the padding. So what is padding? I'm gonna show you a very useful picture. You see here, the purple area is actually our actual image, and we usually pad with some zeros outside this true photo. So why? Actually, after the convolutional layer, the width and height of the picture gonna decrease, but with this padding, it will remain the width and height. So how to compute the padding? The padding size equals to the kernel size minus the stride and over 2. So here 3 minus 1 and over 2 we get 1. So we got this. After the convolutional layer, it's gonna follow the value. It's a very good active function. And then we're gonna follow with max pooling. Max pooling, there is a parameter which is kernel size. I will set 2. What does this 2 mean? 2 means every 2 features we're gonna select the biggest one and make the photo more condensed, more dense. So this is our basically our first layer. So I'm gonna build one more layer, and it also follows a similar pattern. So I'm gonna just copy and paste here. The different part is this: the input channels should follow the output of last layer 16. So you know here what we're gonna input here, right? 16. And then we're gonna double our features, double our filters. I will set 32. Actually, you can set random numbers like 30, 40, or 50, but usually we double this. And follow an active function and the max pooling. So here we finish the convolutional. We're gonna put in the fully connected layer. I'll set the first fully connected layer, which is still linear. Linear, the input of linear is the flatten out of our 3D dimension photo. You see here, after the convolution, our photo gonna be a 3-dimension photo. So here we're gonna flatten it. So the input is the pixels we need flattened. So basically, after all the convolutional layer, because I said with the padding, the width and height won't change. While our initial input is the 1 times 28 times 28 times photo, but you see here max pooling, we have max pooling here. Max pooling, what does max pooling do? It decreases, it halved the width and the height of the photo. So here it becomes 16 times 14 times 14. And we have one more max pooling here, so the result gonna be 32 times 7 times 7. So here the input gonna be 30 times 7 and 7, and I want the output to be 120, and I'll add one more linear fully connected layer. The input is 122, the output is 10 because we have 10 classes. So here basically we finish our definition of these functions. So here we're gonna do the forward propagation, and which the input is x. X is actually our photo. So the x gonna go through our first convolutional layer, and then, oh well, this is tedious, repeating work. The second convolutional layer. So here we are at here, we finish all the convolutional work, so we're gonna flatten this photo. So the function we're gonna use is x dot view and x dot size 0 and the -1. X dot size is actually like the shape function in NumPy. We're trying to detect the first dimension of the photo. So the first dimension is actually the batch or number of rows that input in one training. The -1 means we let the computer to compute rest of dimensions. So after this, we're gonna have our fully connected layer, which is FC1, and we put in our X. So what we need to do here, one more thing we need to notice, we need a sigmoid function. We need to activate the output. And finally we get our output, and it's gonna go through our final layer. It's also a fully connected layer, and we need to return our output. Okay, so here we finish our neural network. So after this, we're gonna initialize an object for class CNN. Of course, we need to import these modules first. Yes, so what we need to do, let's just finish the forward part. We need to do the back propagation. So we need a optimizer, and we need a loss function. For classification problems, we usually use a cross entropy loss. So with this, we can do the back propagation and to do our training. So basically, I will stop our introducing here because all the things you just need a training data and to put into your network. So this is basically the structure of the neural network. And thanks for watching.